Newton's third law of motion states that every action has an equal and opposite reaction. This means that when one object exerts a force on another object, the first object experiences the force that it exerted in the opposite direction. Newton's third law states that forces come in pairs. When an object pushes another object, it experiences the same force in an equal and opposite direction. That's another point about Newton's third law, is that the force experienced by the object as a reaction force is in the same magnitude and opposite direction. The objects will not necessarily experience the same acceleration, although it's the same magnitude of force that is acting upon them, because they can be different masses. So an object with a larger mass, if an object hits it at a certain speed, it will not necessarily go at that exact same speed, because the acceleration it feels is dependent on its larger mass. So its larger mass will make the acceleration it feels smaller, and vice versa if it's a smaller object. Here's an experiment demonstrating that different masses experience different accelerations when the same force acts upon them. In this experiment, the lacrosse ball traveled 4 inches in a matter of 0.1325 seconds. This gave it a speed of 30.19 inches per second, or 0.765 meters per second. Now the wiffle ball in this instance traveled at 0.117 meters per second, proving that an object with a lighter mass will experience a greater acceleration if the same force is applied. When the experiment was run in reverse, the wiffle ball traveled 4 inches in a matter of 0.065 seconds, giving it a speed of 61.54 inches per second, or 1.56 meters per second. This moved the lacrosse ball at 0.017 meters per second, proving that an object of heavier mass, when an object of lighter mass enacts a force upon it, will experience a smaller acceleration due to that mass difference.